Hey, I'm Dave. Welcome to my shop. Today in Dave's Garage, we're going to look at perhaps one of the most misunderstood but essential parts of any serious PC setup, the uninterruptible power supply, or UPS. And if you've always just assumed that they're all about the same, just black boxes with batteries inside that get you through a short power outage, you're in for a surprise. There are several different categories of UPS that operate very differently, and understanding those differences is just the first step in selecting the right one for your own setup. The question isn't whether you should be running a UPS, but rather which one. For reasons we'll cover shortly, if you value either your time or your hardware, or ideally both, you really do need the protection that the right UPS can afford you. I'll take you on a tour of all the technologies and how they differ, including their relative benefits and trade-offs. Along the way, we'll look at multiple different solutions and technologies ranging up to a 240-volt backup for my welder and even a solar-powered AMD Threadripper. Now, you likely know that a UPS is a device that provides continuous power to a computer and its peripherals during power outages, fluctuations, or other disturbances. The benefits of using a UPS on a computer are numerous, so let's look at just a few of the most important ones. System uptime. The most obvious benefit is that a UPS keeps equipment online for better uptime, as it maintains continuous power to the computer, allowing it to stay online during power interruptions. This ensures that work is not disrupted, and more important, that data is not lost. Safe shutdown. A UPS provides sufficient backup power to enable the computer to shut down safely in the event of a power outage. This is particularly important for Windows-based systems, which seem to be a little prone to booting problems when not shut down properly. It usually requires a USB or serial connection from the UPS to the PC, and that communication channel allows the UPS to notify the PC when a shutdown has become inevitable, either because of a set amount of time has elapsed or the batteries are running low. Using that knowledge, your PC can save its data, flush the caches, and do an orderly shutdown. It sure beats coming back to an unbootable system. Power protection. With a UPS, you get protection from various power-related issues such as blackouts, which are the complete loss of power, brownouts, which are reduced voltage, power sags, which are short-duration voltage drops, and voltage spikes where the voltage goes too high, and surges, which are longer-duration high-voltage events. These disturbances can cause hardware damage or loss of data, or both. If you're in an area prone to lightning, a UPS might be able to help there as well. In the event of a lightning strike on a nearby transformer or buried cable, most UPSs will be able to react fast enough to break the line and protect the PC. But you have to remember that lightning strikes can produce incredibly high voltages, which means that a sufficiently energetic arc could still jump the internal contacts of the UPS and make it through to your equipment anyway. Really depends on where it hits and how hard. Noise filtering. UPS devices often have built-in noise filtering, which helps protect the computer from electrical noise that can interfere with the proper functioning of the system. Frequency protection. A UPS can correct AC frequency shifts and protect against phase loss, which can occur when one or more phases in a three-phase power supply are interrupted, if you're on three-phase power. A sufficient phase shift can cause the computer to malfunction or suffer damage, most likely in the PC's power supply. Data protection. A UPS allows for safe, orderly shutdown of the computer in the event of a power outage, as noted, reducing the risk of data corruption or loss. If you were in the midst of saving a file when the power dropped, that file would be lost and it might damage the file system structure on the disk. This risk has been mitigated somewhat by the common use of journaling file systems like NTFS, but even if your disk remains intact, the data you were working on is likely gone. Peace of mind. Knowing that your computer is protected from power disturbances and potential damage can give you a certain amount of peace of mind, especially for businesses relying heavily on their computer systems for daily operation. Imagine you had a PC running a point-of-sale terminal in a store, like a cash register. You may not think you need a UPS, since the customers wouldn't be actively checking out during an outage anyway. But it buys you the peace of mind that comes with knowing that when the outage is over, your system is still going to be bootable, functional, and ready to check people out. Before you can really shop for a UPS or even care about the different types that are available, the first question you really need to ask yourself is how big of a UPS you actually need. One thing that had long confused me was the fact that many, if not most, UPS manufacturers rate their boxes in VA or volt amps. Since I was just taught that watts are equal to volts times amps, I always just assumed that VA was synonymous with watts. I bought a 1500 watt UPS for my main workstation because my machine has a 1200 watt power supply, and even with the NVIDIA 4080 and the Threadripper 3970 running at full clip, it still was well under the power supply limit. I only had some other incidental accessory loads, so I figured that 1500 VA would more than cover it. The first time I ran a GPU benchmark, however, the UPS started complaining. Red LEDs came on and it made an alarm system tone and told me that the system was overloaded. But how could that be? Well, while I was correct that watts can be calculated by multiplying volts by amps in a simple DC circuit or purely resistive AC circuit like a stove or a light bulb, it's slightly more nuanced than that in some cases. That's because in AC circuits with reactive loads, which means those that contain inductors or capacitors, the relationship between volts, amps, and watts becomes more complex. Reactive loads introduce a phase difference between the voltage and current, leading to the concept of apparent power, measured in voltamps, and real power, measured in watts. Now at first, that sounded something like imaginary numbers to me, but I continued to dig into the issue. It turns out that apparent power, also known as VA, is the product of the voltage and the current in an AC circuit without considering the phase difference between them. Real power in watts, on the other hand, takes into account that phase difference and represents the actual work being done by the electrical load. So in AC circuits with reactive loads, the power factor comes into play. The power factor is a quote-unquote dimensionless number between 0 and 1, which indicates effectively how the electrical power is being converted into useful work. A power factor of 1 means that all the power is being converted into real power, while a power factor of less than 1 indicates that some power is being wasted as reactive power. To illustrate what happens when the power factor isn't 1, let's consider a simple example. Suppose you have an AC circuit with a voltage of 120 volts and a current of 2 amps and a power factor of 0.8. To find the real power in watts and apparent power in voltamps in this circuit, you can use the following calculations. Apparent power, measured in VA, is equal to your voltage V times your current A. So 120 volts times 2A is 240 VA. The real power in watts is equal to the apparent power that we just calculated times the power factor. So 240 VA times 0.8 is 192 watts. In this example, the real power of 192 watts is less than the apparent power of 240 VA due to the power factor being 0.8, indicating that only 80% of the apparent power is being converted into useful work. So you would need 240 VA of capacity to run your 192 watts. This difference between watts and VA becomes crucial when sizing electrical components like UPS devices or also transformers and generators. Equipment must be sized to handle both the real power in watts and the apparent power in VA in order to ensure safe and efficient operation. In practice, this means often selecting equipment with a higher VA rating than the watt rating to accommodate the effects of the power factor. Quite honestly, the best way to do it is with a power meter like the kilowatt. Now, everybody should have a couple of these handy devices, and I'll put a link to one in the video description in case you've been alive this long and somehow survived without one. The meter plugs in between your cord and the wall outlet and tells you a great deal of information about the load you're demanding and the quality of the power signal. In my case, I use the meter that's built into my big Delta Pro lithium backup system, which we'll talk more about later. Just running a typical load, the workstation, including the monitor and accessories like the mouse and so on, was drawing about 600 watts. To really get the juice flowing on the PC, I decided to temporarily do some mining, since I knew that would max both the CPU and the GPU at the same time. When I did, I saw a bump of more than 500 watts to almost 1200 watts. Any extra load beyond that, like trying to turn on my Mac Studio that was also plugged into the same UPS, would simply trigger the UPS fault. Still, it was well within its limits for just the PC workstation. So before settling on a UPS size, don't guess. Measure your needs and then add a little capacity for headroom and you should be fine. Once you've settled on the power limits that you need to satisfy, you can start worrying about battery capacity and runtime. Now, if you're lucky enough to have an automatic standby generator connected to your home or business, all that really matters is that the UPS has enough runtime to bridge that gap between when the utility power goes down and the generator comes fully online. If you don't have an automatic genset and automatic transfer switch, then you have to decide if you want the system to be usable for any real amount of time or if you just care about an orderly shutdown to protect the machine and its data. The APC 1500 on my workstation can supply 100 watts for about 3 hours. That means it can supply a more reasonable load like 1000 watts for about a tenth of that or just about 18 minutes. Not much time to get any real work done, but plenty to provide a safe shutdown. The extreme power UPS on my server rack is 3000 VA, and at the 20% load that it averages, it can sustain the entire server rack for about a full hour at least. That includes running several mechanical panels as well as all of the PoE networking around the house, which keeps the Wi-Fi up and the cameras up and everything else alive during power outages as well. Two main factors in UPS sizing then are power limits and battery capacity. So start by sizing your UPS to the maximum power it will face and then decide how long you need to run it at for average loads and use that to select the battery size you need. Now obviously, all UPS units have a battery of some kind, but there are multiple different kinds. The most common at the consumer level is the good old lead-acid battery, not unlike the one that cranks over your grandpa's old GMC pickup truck in the dead of winter. Lithium-ion batteries are more like the battery you'd find in a laptop when you're writing your screenplay at Starbucks, and there are significant differences between the two types. Each type of battery has its own set of advantages and disadvantages. Believe it or not, the lead-acid UPS battery has a few virtues, such as cost. Lead-acid batteries are generally less expensive than lithium-ion batteries, making lead-acid UPS systems more affordable. That's about it for virtues. Let's have a look at some of the disadvantages of lead-acid batteries relative to lithium-ion. Weight. Lead-acid batteries are significantly heavier than lithium-ion batteries, which can be a drawback when considering portability or installation requirements. Lifespan. Lead-acid batteries typically have a shorter lifespan than lithium-ion batteries. They usually last around 3 to 5 years depending on usage and maintenance. If nothing else, you'll wind up replacing the lead-acid batteries every couple of years, sometimes as long as 3 to 5 as I said, but lithium-ion batteries can last much longer, particularly if they're not cycled often. Environmental impact. Lead-acid batteries use lead, which is toxic and can cause environmental harm if not properly disposed of or recycled. Energy density. Lithium-ion batteries have a higher energy density compared to lead-acid batteries, which means they can store more energy in a smaller and lighter package. Even if you're not concerned with having to move a heavy UPS around, the power density means that a lithium-ion UPS can be significantly more compact. Now that we've covered the capacities, we can talk about the technologies behind them. The first thing you need to worry about is the power waveform. As you likely know, the AC waveform coming in from the power utility is a near-perfect sine wave oscillating at 60 Hz, at least here in the USA. That waveform is generated from the motion of the generator rotor spinning within the stator magnets, so it's a natural outgrowth of that process. However, absent a physical generator, if a UPS is going to simulate that waveform, it's going to have to do so electronically with an AC to DC inverter of some kind. Good inverters are expensive, which is why you don't find them in every UPS. The most basic UPS units, which you should probably avoid at all costs, simply create a square wave. The power waveform cycles between up and down sharply at 90-degree angles and should be sufficient for running small power tools and so on, but such UPSs have no place in running sensitive electronics. That's why you want to look for a UPS that has what is known as a sine wave inverter. It recreates the smooth sine wave that you'd see from the utility power. Now that we know that we want a sine wave inverter, we come to the point where it's time to learn about the three major types of UPS technology, which are offline or standby, line interactive, and online or double conversion. Each type has its own set of benefits and drawbacks depending on the specific requirements and applications. Offline or standby UPS. An offline or standby UPS is the most basic type of UPS. It provides very minimal protection and is best suited for less sensitive equipment. The UPS stays in standby mode when the mains power is stable. In the event of a power outage or voltage fluctuation, the UPS then switches to battery power to provide backup power to the connected equipment. There are a few benefits to an offline UPS. They're cost-effective. Offline UPS systems are generally the least expensive option. They're also simpler overall. They have fewer components, making them easier to maintain and repair. They also have superior energy efficiency. Since they're not always engaged, they consume less energy as long as the mains power is stable. Offline UPSs, however, come with several drawbacks. They offer basic power protection only and may not be suitable for sensitive or critical equipment such as the computers that we're primarily concerned with here today. They also have a slow transfer time. The switch from mains power to battery power can take a few milliseconds, which may be too long for some sensitive devices. Many computer power supplies can't buffer or bridge that gap, and your system may reboot even though it never fully loses power. The next type of UPS is known as line interactive. A line interactive UPS is a more advanced type of UPS that offers better protection and is suitable for a wider range of equipment. The UPS actively monitors the input voltage at all times and uses a built-in automatic voltage regulator to correct minor voltage fluctuations without switching to actual battery power. In the event of a power outage or significant voltage fluctuation, the UPS then switches to battery power to provide backup power to the connected equipment. A line interactive UPS has a number of benefits, including better voltage regulation. The built-in automatic voltage regulator helps to correct minor voltage fluctuations, reducing the need to switch over to battery power. That also preserves the life of your batteries. Faster transfer time. The switch from mains power to battery power is quicker compared to offline UPS systems, providing better protection for sensitive equipment. Moderate cost. Line interactive UPS systems are typically more expensive than offline UPS systems, but cheaper than the full-blown online UPS systems. Energy efficiency. As long as the power is in good shape, they consume less energy than the online UPS systems. Of course, there are a couple of drawbacks to line interactive units as well. While offering better protection than an offline UPS system, they still may not be enough for highly sensitive or critical equipment. They still need to switch between battery and line power, and that can cause things like the AC sine wave to suddenly reset, which can disrupt more sensitive devices like those that might rely on the AC waveform for internal timing. Further, they're not ideal for environments with frequent voltage fluctuations. The unit can only handle minor voltage changes, so it may not be suitable for areas that experience significantly unstable power supply. Finally, we come to the best kind of UPS, the online style or double conversion. An online UPS is the most advanced and provides the highest level of power protection. The online UPS continually converts the incoming AC power to DC power, and then back to AC power, thus providing a continuous and stable power supply to the connected equipment. This double conversion process isolates the output power from the input power, ensuring a clean and stable power output regardless of the input power quality. Because it's always converting the AC to DC and then back to AC, the battery simply sits in the middle of this process. If the line power drops out or down, the battery takes over, supplying the DC side. When the AC power comes back on, it will again be converted and feed the DC side, allowing the battery to be recharged. For minor drops in input power, the battery can lend as much or as little power as is needed to make up the difference. An online UPS offers a number of benefits, such as the highest level of protection. Online UPS systems offer the best protection against power outages, voltage fluctuations, and other power-related issues, making them ideal for sensitive and critical equipment. Zero transfer time. Since the UPS is continually converting power, there is no transfer time when switching to battery power, providing seamless protection for connected devices. Wide input voltage range. Online UPS systems can handle a wide range of input voltage fluctuations, making them suitable for environments with unstable power supplies. If you ever connect your house or even just the PC itself to a generator, the online UPS gives you some peace of mind because you know the power output will still be completely clean even if your generator isn't perfect. Superior power quality. The double conversion process ensures a clean and stable power output, minimizing the risk of damage to things like PCs. They do come with a few drawbacks, however. Higher costs. Online UPS systems are typically more expensive than offline and line interactive UPS systems due to their advanced features and components. Energy efficiency. The continuous double conversion process consumes more energy than offline and line interactive UPS systems, leading to lower overall energy efficiency. As a result, you get increased heat generation. The continuous conversion process can generate more heat, which may require additional cooling measures to maintain the optimal operating temperatures and to ensure the longevity of the UPS system and your connected equipment. In summary, the choice between offline or standby and line interactive and online or double conversion UPS systems depends on the specific power protection needs, just how sensitive the connected equipment is, and your available budget. Offline UPS systems are suitable for less sensitive equipment and are the most cost-effective option. Line interactive UPS systems offer better voltage regulation and faster transfer times, making them suitable for a wider range of equipment. Online UPS systems provide the highest level of protection and are ideal for critical and sensitive equipment, but they come with higher costs, a bit of extra heat, and some increased energy consumption. I think most of these drawbacks are pretty minor, and if your budget can swing it, then an online UPS is the way to go. Back when I was in college, my father-in-law ran the IBM data center in my hometown, and he was responsible for all the facilities, including the UPS for the entire office building. Like a consumer online UPS, it was set to continually convert the incoming AC, whether from the utility or generators, into DC to keep the batteries full. Those batteries were made up of huge banks of 1.5-volt lead-acid float batteries that completely filled a very large room. The battery power was then always continually converted back to sine wave AC, and in that way, if the power ever went out, everything would be running off the batteries as if nothing ever happened until the big diesels kicked in. Those generators then simply took the place of the utility power, charging the batteries back up as needed and powering the AC to DC to AC conversion process. As a more practical example of an online UPS, let's take a look at my Extreme Power P91. It's the 3000 watt version, which means you need a 25 or 30 amp outlet just to power it fully, but smaller versions are also available. The Extreme Power P91 3000 watt UPS is a double conversion, fully online system designed to provide power protection for the most sensitive electronic equipment. Perhaps its best feature is the double conversion topology. The P91 is an online UPS that provides consistent and clean power to connected equipment through its continuous double conversion process, ensuring the highest level of power protection. With a 3000 watt power capacity, this UPS can support a wide range of devices and applications, including servers, data centers, and networking equipment. I use it to power the entire server rack, all of the PoE Ethernet, including a dozen Wi-Fi access points and a similar number of security cameras. This means that even if somebody cut the power to the house, the security systems remain fully functional for hours. The P91 3000 watt UPS even allows for additional battery packs to be connected, and this can extend the runtime during power outages, ensuring your equipment remains operational for longer periods. You can even hot swap batteries in the UPS without taking it offline. The UPS is equipped with automatic voltage regulation, which ensures that the output voltage is maintained within an acceptable range, protecting the connected devices from any voltage fluctuations. The P91 also features an intuitive LCD display that provides real-time information about the UPS status, kind of like the Toyota Prius thing where it shows you where the power is going to the battery, to the motors, and where it's coming from and going to. And it has a bunch of other critical parameters, so it enables easy monitoring and management. It also supports full SNMP management using an optional network adapter. I've had the P91 running in my home lab server for about 6 months now, and it's been entirely bulletproof, reliable, and maintenance-free. So I've got no reservations in recommending the Extreme Power product line as long as you've got the budget for it, because you do get what you pay for. Finally, we can look at double backups. Now, I'm not claiming it's an efficient way to do things or necessarily even a good idea, but in 2 cases I have a UPS connected to a UPS. For my main workstation, as we discussed, I have an APC 1500 unit, but that unit is not plugged into the wall. Rather, it's connected to an Ecoflow Delta Pro portable lithium generator. These are big units at over 100 pounds, and they're based on lithium iron phosphate batteries. The Ecoflow Delta Pro has a huge capacity. It's rated for 3600 watt hours, meaning it can run my workstation for about 5 hours after the power goes out. Because I'm feeding the APC UPS off the Delta Pro, you might think there are needless losses introduced, but I don't think that's the case. Since the APC unit is line interactive, it effectively passes the power straight through as long as it's within spec, which it always should be since it's coming right out of the Delta Pro. The Delta Pro is equipped with numerous ports, including 12 volt, 120 volt, and even 240 volts when you have a pair of them, as I do. Make sure you're subscribed to the channel, as I'm going to test it for quick charging a Tesla, running the shoplift, welding, and so on. It also supports USB-C power delivery for running or recharging power-hungry laptops like the MacBook Pro. It features 2 charging rates, the faster of which will recharge the batteries from empty to full in about 5 hours. If you hook it up to your car's electric car charger, you can cut that time in half. I also have a bank of 21 solar panels plugged into the Delta Pro, and it preferentially uses that power before drawing from the grid. The panels typically don't exceed the demands of the workstation, but on a good day they do offset a major portion of the power it consumes, meaning my Threadripper is solar powered. This is all functionality automatically provided by the Delta Pro, which features a standard DC solar panel input port. Now, UPS management is beyond the scope of what I've got time to cover here today, but there's one essential component that I skimmed over earlier, a connection from the UPS to the PC so that the UPS can inform the PC when the power is going to go down, if it has to. That advanced notice allows the PC to do an orderly shutdown, which affords you all the data integrity benefits that we spoke about earlier. Now, Windows itself can interface with most every common UPS, and for those that it can't, you're stuck with whatever it comes with for bundled software. But whichever route you go, make sure you get that one piece of communications working properly. Thanks for joining me out here in the shop today. Now remember, I'm mostly in this for the subs and likes, so if you enjoy this episode, please be sure to leave me one of each before you go today. And if you or someone you know may be on the autism spectrum, check out the free sample of my book on Amazon, Secrets of the Autistic Millionaire. It's got nothing to do with money and everything to do with living a successful life on the spectrum. It's everything I know now that I wish I'd known back then. Check the link in the video description. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage.
Do it, Glenn! Do it! Do it!